This is Daryl with Cisco Hands-On Training. Today it's the 22nd of February 2009, and today we're working on 802.1q and interswitch link trunks. The website is ciscohandsontraining.com. The diagram is on for today's episode is on the website in the comments. In iTunes, you can subscribe by searching on Cisco Podcast, and please link to my webpage. And what is a trunk? Well, in networking, let's talk about the problem. In the last episode, we had VLAN 1 configured on switch 1, and VLAN 1 configured on switch 2, and VLAN 1 configured on switch 3, and we built a triangle, and that was all great. But the cool things about switches is you can have multiple VLANs, and each VLAN is its own separate broadcast domain. So I could have 7 VLANs on this switch, and 5 VLANs on this switch, and 4 VLANs on this switch. Let's say I build a data center, or I build a building where I have like 20 switches interconnected. I have the 2 distribution switches, and then I have 18 access switches hanging off of them. And I have 10 different departments, and I decided to put the 10 different departments on 10 different VLANs. Well, okay, that's great, but I want to have 10 different VLANs on each of these switches, on each of the 18 switches, so that way it doesn't matter where people sit or are physically cabled in the building. I just configure the switch port to put them onto the right VLAN for their department. That means I have 10 VLANs that need to connect between switch 3 and switch 1. Well, that link we configured in the last episode only had 1 VLAN on it. So what am I going to do? Am I going to configure 10? Am I going to go in and cable these guys 10 times, one on VLAN 1, one on VLAN 2? No, I don't want to go there. What I want to do is I want to be able to have one link go and run all 10 VLANs over it. And that's what network engineers call a trunk. Now, a little problem with nomenclature is that a lot of systems people, particularly sysadmins that learned on Sun Microsystems, they consider a trunk when you take two Ethernet cables and you bind them together into one. Like if you have 2 100 meg Ethernet cables, if you bind them together into one 200 megabit channel. Now, network engineers call that Ether channel. Network engineers call it a trunk when you run multiple VLANs over a link. So don't get confused about the terminology, especially if you're an old sysadmin. To network engineers, a trunk is a physical link that runs multiple VLANs over it. There are 2 ways to configure. There are 2 trunk formats. There's the 802.1q format, which is the modern vendor-independent format, and then Cisco had a proprietary interswitch link format called ISL, which is now historic, although you might run onto it in some older switches. Old Cisco switches ran, when you configured trunks, old switches ran ISL by default. On modern switches, they run 802.1q by default, and really modern switches only speak 802.1q and don't even talk out the old ISL format. Here's a web page at Cisco where they have the ISL frame format and the 802.1q frame format in it, and I found it thanks to Google nice and easily. And the ISL frame format is, the ISL frame format, basically what you do is you have an ISL header, and then you have your frame, which is your standard Ethernet frame, and then you have a checksum at the end. And the ISL header has a, inside the ISL header, it has the 15 bits allocated to the VLAN. So basically, VLAN 7 will have 7 in binary inside these 15 bits, and that way, when you have a frame in VLAN 7 that needs to go over the trunk, the switch, as it spits it out, will put an ISL header in front, and inside that ISL header, it'll code VLAN 7 here. And then when switch 3 receives the ISL frame format, it will, the ISL encoded frame, it will look at the frame, it'll see that VLAN 7 is encoded here, it will take the ISL header and the FCS off of the frame, and then it will take the frame that is encapsulated and output it onto VLAN 7, and then forward it in however way it's supposed to on VLAN 7. Okay, that's the ISL frame format. There's a bunch of other stuff in the ISL frame format. I suggest going to the website for detail. The key is in ISL, the header, the frame, you just take your Ethernet frame and you add a header right at the very front and a checksum at the end. And that header has the VLAN encoded in it. Okay, now the 802.1q frame format is a little bit different. Here's the Ethernet frame where you have the destination MAC address, the source MAC address, the type of frame, and then you have your data and your original FCS. And then in 802.1q, what they do is they actually leave the destination and source address at the front. They put the tag in the middle, and then they just rewrite the FCS with the new FCS, which includes the data for the tag. And then the checksum just is just a check to make sure that data isn't garbled. If data gets garbled, that way you know to throw it away. Inside the ISL frame, you have inside the tag, you have the first thing inside the tag is the TP ID, which is based on the website on Cisco, is set to a value of 8100. It's basically going in the place where you'd have the type of the Ethernet frame, and that's basically saying that the type of this frame is 802.1q encapsulated data. And then you have the priority. You have 3 bits for a priority, which is a layer 2 QoS mechanism. So 802.1p and 802.1q are sister protocols, and 802.1p, if I remember right, is the priority queuing protocol, which you can have 3 bits identifying the priority. And that way you can have some frames that are more important than others. And then here at the end you have 12 bits for the virtual identifier, which is the VLAN that you go on. And 12 bits is enough for 4,096 VLANs. Okay, so the 256, 512, yes. So those are the 802.1q frame formats. And let's go ahead and configure a trunk. And here I am on a switch, and if I do a show VLAN, I have VLAN 4 accounting and VLAN 1 default. One other thing important about 802.1q trunks is that there's a concept of a native VLAN. 802.1q is a native VLAN. That's a VLAN that is not encapsulated. By default, VLAN 1 is not encapsulated, and then all other VLANs would be encapsulated. So over the trunk, you will actually have some data that comes through unencapsulated. And that's important because if a hacker gets access to a trunk port, they can inject packets with a if they get access to a trunk port, they can identify the native VLAN and then inject packets with a tag which says put it on another VLAN, and that way the hackers can inject packets on an arbitrary VLAN, perhaps a VLAN that you wanted secure. So you don't want to let hackers get access to a native VLAN, and in general you don't want to allow in general, for security reasons, you don't want to run VLAN 1 to customers. I generally leave the native VLAN as 1 on all of my trunks, and then I just don't let customers use VLAN 1. VLAN 1 is only just for the native VLAN for the trunking. Okay, let's go ahead and do some configuration. Here I am on switch 3, conti VLAN to name engineering. So I got some VLANs now. I got VLAN 1, which is by default. I got VLAN 4, which is accounting. I got VLAN 2, which is engineering, and conft int fast 0/1 switch port mode trunk. I got a ton of log messages. Let's go take a look at what happened. Make forwarding, uplink fast. I got a whole bunch of, I got my old debug on. So no debug all. And then I got all my spanning tree data. We're dealing with trunking today, so show run int fast0/1. I have the logging event spanning tree, and what it's telling me here is that I got VLAN spanning tree is running in a per VLAN spanning tree mode. Show run type include spanning tree. Spanning tree mode per VLAN spanning tree. So I'm actually running a spanning tree instance per VLAN. Show spanning tree VLAN 1. And you can see that the root is out port 3, which is fast Ethernet 0/1. Show spanning tree VLAN 2. This bridge is the root. And that's because I only configured VLAN 2 on switch 3. Show spanning tree VLAN 4. Again, this bridge is the root. And you can see the only interface in VLAN 2 and VLAN 4 is fast Ethernet 0/1 because I don't have any access ports in VLAN 2 and I don't have any, and I only have the trunk in VLAN 2. Show int trunk. So I got a trunk configured on its mode on, which says I just want it to be a trunk. I don't care what the other guy says. I'm not even going to talk to him. The encapsulation is 802.1q. I did not configure encapsulation on this. Conf t int fast0/1 switch port trunk. I'm looking for switch port trunk encapsulation. Switch port trunk encapsulation blah is a command to configure a particular encapsulation. You can configure ISL or you can configure 802.1q, and guess what? It's not there. Why is it not there? Show ver. This box is a 2960. It's a modern enough switch that it does not even support the old ISL trunk format. It only talks 802.1q trunking. Okay, so here I am. I've configured a trunk. My native VLAN is 1. That means that traffic on VLAN 1 is not encapsulated. VLANs allowed on trunk. All VLANs are configured to be allowed on trunk because I have not configured anything. Show run int fast0/1. There's a command that you could use to restrict which VLANs are allowed on the trunk, and I have not configured it, so by default, all VLANs are allowed on the trunk. But the only VLANs that are active in the management domain are VLANs 1 and 2 and 4. Wait a minute. I thought there were some more VLANs in the domain. There's these, you'll find that there are these VLANs 1002, 1003, 1004, 1005, which are always in existence on your switches, and it's the old FDDI. FDDI is an old fiber distributed data interface, which was an old 100 megabit backbone technology back when 100 megabits was a lot of bandwidth. There's Token Ring, which is another ancient competitor to Ethernet that lost because it tried to be more deterministic than Ethernet, and it ended up being more complex, and Ethernet ended up working out better and winning in the marketplace. And then FDDInet and Token Ring Net. So these are old legacy VLANs, which you might see in your show VLAN output, but just ignore them. Pretend they don't exist. And your trunk is pretending it doesn't exist. Show int trunk. Mode on. And then VLANs allowed and active in management domain 1, 2, 1, VLAN 1, VLAN 2, and VLAN 4. And then VLANs in spanning tree forwarding state and not pruned are 1 and 2 and 4. Okay? So that's fine. We've got a trunk, or at least on this end we have a trunk. On the other end, it's still an access port. So let's go ahead and go to the other end and just for kicks, show run int VLAN 1. Let's conf t int VLAN 2 IP address 10.1.2.4 255.255.255.0. Let's see what happens. Show run int VLAN 2, show IP int brief. And it looks like the IP address is up on VLAN 2, which is not quite what I expected. I was expecting, because this is a layer 2 switch, to have that IP address not be operational. Ping 10.1.2.4. I'm pinging my own IP address, and I can. Ping 10.1.1.4. Interesting. Show IP route. Okay. Okay, let's go to the... okay, here I am on switch 1. Show run int fast 0/3, and I'm going to get rid of the spanning tree guard root. Conf t int VLAN 2 IP address 10.1.2.2 285.285.285.0. Show int VLAN 2. So look at this. VLAN 2 is down, line protocol is down. Show IP int brief. If I do a show IP int brief, VLAN 1 is up and VLAN 2 is down. Let's look at the difference in our config. Show run int VLAN 1, show run int VLAN 2. What's the deal? There's no difference in our config. Okay, well, the problem is that VLAN 2 does not exist on this switch. Show VLAN. I've got these default VLANs, which don't really exist, and I've got VLAN 1, which was the default. I don't have a VLAN 2, I don't have a VLAN 3. I mean, I don't have a VLAN 2, I don't have a VLAN 4. I created those VLANs down here on this switch, and that does not magically make those VLANs go off to these other switches. In order to, if you want to configure VLANs on one switch and have those VLANs automatically exist on all switches in a particular switching domain, then you need to use a protocol to do that. And actually there is such a protocol. It's called VTP, the VLAN Trunking Protocol. And we will cover that in the next episode. Right now we're just configuring bringing up trunks. That means in order for our network to work, we're going to have to manually configure all of 3 of our VLANs on all 3 of our switches, which is a pain in the neck. And it's error prone. It's not just a pain in the neck, it's error prone. If, for example, I configured VLANs 1, 2, and 4 on these 2 switches, but I only configured VLAN 1 on this switch 2 up here, then my connectivity would appear to work, because any hosts on VLAN on switch 3 would be able to, get off to my routers or wherever they need to go. But if this switch went down, like if I rebooted it to do a code upgrade, then VLANs 2 and 4 on this switch would no longer have access out of the environment. And that would be because of the configuration error. So one thing you want to do as a network engineer is you want to use protocols to try to prevent. You want to use protocols to try to prevent configuration errors from causing outages and eliminating redundancy. That's one of the reasons why we use dynamic routing protocols as opposed to static routing protocols, and that's an advantage of using VTP, because VTP will cause VLANs created in one place to spread out through your environment. And we'll talk more about VTP in the next episode. VTP does have downsides. The upside is that VLANs created in one spot can spread through your environment. The downside is that VLANs created in one spot can spread throughout your environment, and that can be dangerous too. But I'm sorry, I'm digressing. That's next episode. Right now, we just want to configure a trunk on switch 1. So, show VLAN. Oh yeah. I'm sorry, the whole point was our VLAN didn't exist. Conf t int VLAN 2. Actually, I don't want int VLAN 2. Int VLAN 2 configures a layer 3 interface. What I want to do is configure a layer 2 instance, which is a layer 2 spanning tree broadcast domain, VLAN 2. And what was the name on the other switch? I think for VLAN 2 it was engineering. So let me misspell engineering just for kicks. Oh, name engineering. VLAN for accounting. Name accounting. And this is interesting. I still have some, I still have my spanning tree stuff, and you can see that the spanning tree is running on a per VLAN spanning tree. So instance 2 of spanning tree for VLAN 2, once I created VLAN 2, then on fast Ethernet 0/3 it went from disable to blocking, and then from blocking to listening, and then listening to learning, and so on. And then show run int fast 0/3, show int trunk. That's interesting. I did not configure a trunk on this port. On switch 3 on fast Ethernet 0/1, I configured trunking mode on. And on switch 1 fast Ethernet 0/3, I have not configured anything. It's the same old config. It's the default config. It's the default config. It's VLAN 1 because that's the default, and I have not configured squat. And look at the trunking mode by default. The trunking mode is what's called auto. So what automatic trunking mode means is that it is willing to, there's a protocol called the Dynamic Trunk Protocol, DTP. And this switch is talking the Dynamic Trunk Protocol out the port. And what auto means is it's willing to become a trunk, but it doesn't want to become a trunk. But if the other side wants to become a trunk, then it'll become a trunk. Now on the other switch down here, I configured mode on, which said I really want to become a trunk, and in fact I actually thought that meant that it won't even speak the protocol. But apparently when you set a trunking mode to on, it still speaks the dynamic trunking protocol, and now fast Ethernet 0/3, because it's mode auto, it's talking to the other end, and the other end says, hey, I'm becoming a trunk whether you want to become or not, so since you're in auto mode, how about you become a trunk? And 0/3 in auto mode says, okay, I'll become a trunk. And VLANs allowed in trunk are all VLANs, but there are only 3 VLANs active in the management domain and 3 VLANs in the spanning tree forwarding state and not pruned. Ping 10.2.2.4, see if it works. Not working. Show IP int brief. So I've got 2 IP addresses on this switch, and they're both up. Ping 10.1.2.4. It helps when you ping the right IP address. So I am able to ping 10.1.2.4, and that ping is actually going out on VLAN 2. So this is interesting. 2960 is even though it's not a router, it allows you to configure multiple IP addresses on multiple VLANs, but it won't route between them. So let's see. I got a trunk up. Show int trunk. Show CDP neighbor. Show CDP neighbor fast 0/3 detail. Now let me conf int fast 0/3. Let's go switch port mode access. So what I did there when I did switch port mode access is I changed this. The switch port mode can be access or auto or desirable or trunk. And access means it's not a trunk, it will just be an access port on VLAN 1. And so what that meant is that for instance 2, spanning tree went basically VLAN 2 and VLAN 4 no longer exist on that port because it's not a trunk. So ping 10.1.2.4 is not going to work because VLAN 2 does not exist on the trunk. let's go and look at what the other switch thinks. So here I am on the other switch, show int trunk, show run int fast0/1. Conf t int fast0/1. I thought I show run int fast0/3, show run int fast conf t int fast0/1 switch port mode trunk. I thought I set trunk. Oh, this is switch 2. Wrong switch. By the way, you know what I just did? I went and configured a trunk port on switch 2 when I meant to configure it on switch 3. That's what we call a human error. Did you know that human errors cause about 1/3 of all network outages in production? You know, people have been known to reboot the wrong server. I remember crashing a NFS file server once when I slipped with a cut and paste and killed a bunch of critical processes. Human errors happen, and you want to try to avoid them, and one way to avoid them is by slowing down a little bit. I went and logged into a different switch, and I was not careful that I was on the switch that I really meant to be on before doing configuration. In any event, but that's also why you do training in the lab. In the lab, you can relax and just play around. So show run int fast0/1, show int trunk. Now look, I'm still trunking here. Fast Ethernet 0/1 is trunking, and Fast Ethernet 0/3 is in mode access, so it is not trunking. So let me ping 10.1.1.2. I can still ping 10.1.1.2, which is going on VLAN 1 between these boxes. How is that possible? I thought the trunk meant that the frame format was changed, and because the frame format's changed, and the other side is, since I'm putting this 802.1q frame format on the frame, that it would the other side would not understand it because it's in access mode. Well, the answer is because of the native VLAN. The native VLAN of the trunk is 1, and in 802.1q, the native VLAN is not tagged. So VLAN 1 just happens to work across this link. Now VLAN 2 would not work because the other side is switch port mode access on VLAN 1 only. So if I ping 10.1.2.2, that's not going to work because I'm going to encapsulate this data in VLAN 2 and send it out the port, and the other side won't even receive it. Now let me try something else. Here I am back on switch 1, conf t int fast0/3 switch port access VLAN 2. So what I did here is Fast Ethernet 0/3 is now in VLAN 2, so that's an access port. So, but on switch 3, Fast Ethernet 0/1 is a trunk with the native VLAN of VLAN 1. So what that means is that VLAN 1 on this traffic on VLAN 1 from switch 3 will not be encapsulated, and traffic on VLAN 2 in switch 1 will not be encapsulated. So VLAN 2 on switch 1 is going to talk to VLAN 1 on switch 3. And meanwhile, switch 1 is sitting here complaining because it's receiving 802.1 encapsulated frames on a non-trunk port, and it ends up, it's detected what's called an inconsistent port type. So, and it has what's called, you get these native VLAN mismatch errors. So show IPnt brief. show int fast0/3. It's up. And I'm getting continuous native VLAN mismatch error messages. Show spanning tree. Show spanning tree VLAN 1, I'm the root. Show spanning tree VLAN 2. Fast Ethernet 0/3 is in type inconsistent mode. So I think what it's doing is it's saying it's to prevent a loop in these types of situations where you have VLAN 1 in one spot and VLAN 2 in another spot can be sort of dangerous. So it's detected that it is inconsistent. Let me, since VLAN 2 on this guy is talking to VLAN 1 on this guy, let me try an experiment. Show run int VLAN 1, show run int VLAN 2, conf t int VLAN VLAN 1, no IP address, shut down, int VLAN 2, IP address 10.1.2.2, 255.255.255.0. Show run int VLAN 2. So VLAN 2 now has the IP address that was on VLAN 1. Ping 10.1.2.4. See if this works. Not working. I was sort of expecting this ping for 10.1.2.4 to go out fast Ethernet 0.3 on VLAN 2, which is not encapsulated, and then fast Ethernet 0/1 on the other side, the not encapsulated would be on VLAN 1 and it would get there. Show run int fast 0/3. Show ARP. That's an old, oh, that's my own IP address. Show MAC dash address table. And the only MAC address table entry I have right now is the router. So I tried something there. So let's fix our problem, because we've been messing this up as an experiment. Show run int fast 0/1, conf t int fast 0/1. Actually, int fast 0/3 is the port going to switch 3. Do show run int fast 0/3. Note that was interesting. That's the do command. You can be in interface configuration mode and you can type in do and then something. And if it's a modern device, and the 2960 is modern enough, it will do whatever you do as if it were a from exec mode. So I can do a show run while I'm in interface configuration mode. So switch port, access VLAN 1. So we set our native VLAN to 1. And then switch port, mode, dynamic, desirable. Let me go auto. Show run int fast 0/3. And let's build our whole net right. Conf t int fast 0/2. Switch port, mode, dynamic, auto. Switch port, mode. Okay. Show run int fast 0/2. Show run int fast 0/3. Okay, so in fast Ethernet 0/3, I just configured it to be native VLAN 1, and I configured the switch port mode to be dynamic auto. Switch port mode, dynamic auto. And those configs did not get into here. Well, what does that mean? What that means is those commands are the default. The default VLAN is VLAN 1. The default mode is automatic. And now you can see that spanning tree is moving from listening to learning to forwarding, and so I'm able to, now spanning tree is now working between those boxes. Show run int VLAN 2, oops, conf t int VLAN2, no, show run int VLAN1, conf t int VLAN, int VLAN1. Yeah, I made a mistake when I was trying my plan earlier. Let's go back to our experiment. Switch port mode access. Switch port access VLAN2, and then int VLAN2 IP address 10.1.1.2. 255.255.255.0. Show run int VLAN2. Show run int fast0/3. Okay, so I'm back to having my native VLAN. I'm back to having fast Ethernet 0/3 being on VLAN2, and the IP address is the IP address that should be on VLAN1. Meanwhile, on switch 3, the trunk is in mode on, so it's going to be trunking whether we like it or not, and its native VLAN is 1. So unencapsulated traffic will go out. VLAN2 traffic will go out unencapsulated on my port, and unencapsulated traffic going in on that port will be interpreted as VLAN1 traffic, and let's see what happens. And then fast Ethernet 0/3 instance 2 moving from learning to blocking due to inconsistent port type. Ping 10.1.1.4. Show spanning tree VLAN2. And you can see that it's designated ports, but it's blocking because of it's in type inconsistent. And so due to the native VLAN mismatch. Okay. So let's fix things. So conf t int VLAN1, int VLAN2 IP address 10.1.2.2 255.255.255.0 int VLAN1 IP address 10.1.1.2 255.255.255.0 no shut int fast0/3 switch port access VLAN1 switch port mode dynamic auto. Show run int fast0/3. We're getting too many spanning tree, too much spanning tree log messages coming out this way. So int range fast 0/1 to 24. No event. No logging event spanning tree. Show run int fast 0/2. Show run int fast 0/3. That logging event status will also give us spanning tree logs. Int range fast 0/1 to 24. No logging event status. That'll clean up our logs on this thing. You can see how the logs spitting out on a console can make it sort of hard to work. In addition, logs spitting out on a console are high priority, and they can actually cause an outage in and of themselves. For training purposes, we leave the logs on, but I'm going to turn off the spanning tree logs for a while because we covered spanning tree in pretty strong detail. So over here on switch 3, conf t int range fast 0/1 to 24. No logging event spanning tree. No logging event status. Show run int fast 0/1. Switch port mode trunk. Show int trunk. So I'm in on mode. My mode is on, which means I've been trunking, and I've always been trunking, whether the other side wanted it to or not. Conf t no switch port mode trunk. Int fast 0/1. No switch port mode trunk. show int trunk. No trunks. Show int fast 0/1 trunk. So fast Ethernet 0/1 is in mode auto, and the encapsulation set to 802.1q, but the status is not trunking. The native VLAN is 1. So the only VLAN allowed on the quote-unquote trunk is VLAN 1. The only VLAN allowed and active in the management domain is VLAN 1. And the VLANs in the spanning tree forwarding state and not pruned are none, which is sort of weird. Let me... spanning tree was just recalculating because I just changed it from a trunk port. You know, I just changed the trunk configuration, so spanning tree went ahead and recalculated. So now we've reached equilibrium, and VLAN 1 is being forwarded there. But guess what? I got my VLAN 2 is not operative now. And the problem is that I'm back to the default config, which is switch port mode auto and auto on both of these ports. And so auto means they speak the dynamic trunk protocol to each other. They're willing to become a trunk, but they don't want to become a trunk. So this guy up here does not want to become a trunk, and this guy down here does not want to be a trunk. So they talk about it, and they agree that they're not going to become a trunk. Whereas before, when this was on, this guy became a trunk no matter what, and this guy, if this guy was auto, then he'd agree and become a trunk. But if he was switch port mode access, then this guy would be in access port mode, and this guy would be in trunk mode, and they'd be inconsistent. So if you want trunks to work between the boxes, you still want to use the dynamic trunk protocol, so that way if you have an inconsistency, it will work itself out. You don't want to just set the mode to on, because if it's on this side, and this side comes up in switch port mode access, then it's inconsistent, and you could suffer the inconsistency could cause you some pain. So int fast 0/const int fast 0/1. Actually, let me be a little bit elegant about it. Int fast int range fast 0/122 switch port mode dynamic desirable. So what I'm doing is I'm saying I'm still speaking the dynamic trunk protocol. I will negotiate with the other side. So if the other side is an access port, then I will not become a trunk. But if the other side is at least an auto port, then I will convince them to become a trunk. Show int trunk. And now I have two trunks. My mode is desirable. The encapsulation is 802.1q because that's the only thing that the 2960 knows. My status is trunking on both fast Ethernet 0/1 and 0/2. And my native VLAN is VLAN 1 on both of those ports. All VLANs are allowed on the trunk, and the VLANs that are allowed and active in the management domain are VLAN 1, 2, and 4. Oh, and guess what? VLANs in spanning tree forwarding state are not pruned. None. Guess what? I'm going through another spanning tree reconvergence here. Just by changing from an access port to a trunk port, spanning tree reconverges, and I take a 30 to 50 second hit. So that's annoying. And uplink fast doesn't help you there. Uplink fast only helps you once you've already reached equilibrium and you're failing over between uplinks. So now I've reached equilibrium and my network is back up. So, you know, going into a data center or something like that and messing with your trunk ports, you definitely need a change window to do it because you're going to cause some spanning tree recalculations while you're doing it. But now I'm done, and my spanning tree forwarding state for all my VLANs is good. Now let's look around. Show spanning tree. So spanning tree for VLAN 1, root port is out fast Ethernet 0/1, and fast Ethernet 0/2 I'm a designated port. Fast Ethernet or VLAN 2 is the same. VLAN 4 is the same. Interesting. Let's go look at switch 2. Here I am on switch 2. Show int trunk. I only have one trunk on switch 2. And the reason is because fast Ethernet 0/3 goes down to switch 3. Switch 3 is mode desirable on its uplink. So because it's desirable and I'm auto, we're both talking the protocol. I'm willing to become a trunk, and and switch 3 wants to become a trunk. So switch 3 convinces me to become a trunk. So I become a trunk. The difference is over to switch 1, I'm in auto, so I'm willing to become a trunk, but I don't want to become a trunk. And switch 1 is willing to become a trunk, but it's also reluctant to become a trunk. So as a result, we mutually agree via the dynamic trunking protocol to not become a trunk. So to fix that, const t int fast 0/1 switch port mode dynamic desirable. Show int trunk. Show run int fast 0/1. Show int trunk. Show int fast 0/1 trunk. So I'm desirable. The encapsulation is 802.1q. Status is other. I don't know what that means. Native VLAN is 1. VLAN's allowed on trunk, none. It's not becoming a trunk. Don't know why it's not becoming a trunk. But it's probably due to the configuration over on switch 1. Here I am on switch 1. Show run int fast 0/2. Show int fast 0/2 trunk. So I'm in mode auto, and if the other side is desirable, then we should have become a trunk, but the status is other, which is weird. Show int fast 0/2. Oh, show int fast 0/2. Oh, my port is down. Line protocol is down. Well, why is my port down? Oh, my cable came out. That's what we call a physical layer problem. So on switch 2, I will plug the cable back into fast Ethernet 0/1. And now maybe my network will work. Show int trunk. So I'm in mode on 5 fast Ethernet 0/2, which goes to switch 2. My mode is auto, so I'm willing to become a trunk. The other side is desirable, so he really wants to become a trunk. We talked the trunk protocol together, and we mutually agree to become a trunk. And VLAN's in spanning tree forwarding state. Spanning tree is still reconverging, so spanning tree is still going over there, is still forwarding to switch 3, but is not yet switching to or forwarding to switch 2. And now it is a little bit later, and I'm forwarding. Okay. So that is the dynamic trunk protocol and 802.1q trunk encapsulation. Again, an 802.1q frame format. It actually embeds an 802.1q frame inside the middle of the normal Ethernet frame, and this tag includes the 12 bits identifying the VLAN. In addition, that's different from the older ISL, where the ISL had the Cisco-proprietary ISL format, which is historic, but you might run into it, just puts a header right on the front of the frame. The important thing about 802.1q is it has the concept of a native VLAN, which is a VLAN which is not encapsulated, and by default that is VLAN 1. It's whatever, so even though it's a trunk, you can still configure switch port access VLAN whatever, and that whatever becomes your native VLAN. You want your switch port native VLANs to be consistent. I recommend using VLAN 1 for your native VLAN, but not to use VLAN 1 for any customers, and that's for security reasons, because you don't want bad customers or evil customers from injecting packets with, they could inject a tag into your net. Now, the other problem with what I just did is I'm playing around, and some of my ports are auto, and some of my ports are desirable, and it's really inconsistent. And it can make troubleshooting a pain. So a general principle in networking is to be consistent. So all 6 of these ports, if I was configuring them for a production environment, I would configure them switch port mode dynamic desirable. And that way, if one port was messed up and accidentally became auto, a trunk would still form and I would not suffer an outage. It would basically take 2 configuration errors to cause an outage. So consistency prevents outages. So while you can play around in the lab, be consistent in production. Write down what your standard configuration is and stick to it. Okay? That's 802.1q trunking. In the next episode, we're going to learn about VTP and how we can avoid creating all of these VLANs on all of these different switches. Because in this lab, we had 3 VLANs on 3 switches. So VLAN 1 was already created for us, so we had to create VLAN 2 and VLAN 4 on all 3 switches in order for the network to work properly. In fact, that's worth one last look. Let's go look at switch 2 and see if we even remembered to do that. Show VLAN. I did not configure VLAN 2 and VLAN 4 in switch 2. So my network here is broken. I do not have redundancy for VLAN 2 and VLAN 4 on switch 3 because VLAN 2 and VLAN 4 do not exist on switch 2. So that's an example of how VTP can sometimes prevent outages by uniformly pushing out the VLANs. Of course, VTP can also cause outages if you uniformly push out the deletion of VLANs that are used for production. But again, that's next episode. Thank you very much.